I'm Anil Kumar. Here is an interesting variation to linear relations. The question here is, Sam is traveling towards New York City at a constant speed. His distance to destination, D, in kilometers, at two different times is given in the table. Estimate the time when Sam will reach destination, right? So that is the estimate we need to do. So what we are given here is that at time 3, distance is 330 kilometers. This 330 kilometers is from New York. You want to reach New York. Let's say you're here and we are approaching towards New York. So at 3, the distance is 330 kilometers. So it is 330 kilometers when time is, let us say 3 p.m. Okay. Now at 5 you must have covered some distance. Let us say at 5 your position is here, right? And then your distance to New York is left 150 kilometers, right? So this is after 2 hours. When we say 5, we are saying after 2 hours, a distance is left is 150 kilometers. From this, we can actually find the speed, right? As you know, speed, distance, and time, their relation is what? Let's make a triangle here to understand. Distance, speed, time. Triangle, right? Distance, speed, and time. Now, how much distance did we cover in 2 hours? So we got speed, we can say, or rate of change. Since it is a direct variation, we could find rate of change, or speed in our case is equals to change in distance divided by change in time, right? Or time taken to travel that much of distance. So in this case, it was 330 kilometers, right? Now the distance decreased to 150. So that is the change in distance, and time is 2 hours, 5 minus 3, right? Well, I interchange this. I know distance is decreasing, right? So we just interchange. We know we don't want to write speed negative. We will keep this as positives. Okay, so it is 330 minus 150. Distance covered in this case is 180 kilometers in 180 kilometers in 2 hours, right? So therefore the speed is 90 kilometers per hour. Do you understand? So 90 kilometers per hour is the speed. Now with this speed, how much time will you take to cover the balance 150 kilometers? That is what we're trying to find, right? So we know time is equals to distance over speed. So in this case, distance left is 150, so we could divide 150 by 90 to get the time. So we'll divide 150 by 90, that is the average speed. We get 5 over 3. In decimals, it is 1.66, 6 recurring, right? So 1 hour and some minutes. To get it in minutes, it is good to write 0.66 times 60 so that we know how many minutes it is. It is approximately 40 minutes. So this is 1 hour and 40 minutes, right? So in 1 hour 40 minutes, distance will be 0. So you'll cover this distance. So now you can fill this up. Distance is going to be 0. That means after 1 hour 40 minutes, you need to add 1 hour 40 minutes. So you get your time. Your time will be 6:40. So at 6:40, Sam is going to reach New York if he continues at the same speed of 90 kilometers per hour. I hope you understand the steps here, right? So we have time to reach will be expected time, right? Will be 5 plus 1 hour 40 minutes, right? That gives us 6:40. So that is the time when Sam is going to reach the destination, right? So that is how you do it. Now, question for you is, let us say that the total distance is 500 kilometers for Sam to cover, right? So my question here is, if New York is 500 kilometers, right? Find the time when Sam started the journey, right? So you could now think about this in a way that, let us say Sam started somewhere before. We need to find this time, knowing that this distance is 500 kilometers total distance. Okay, so that is the question for you. You can try this question. I hope you find it interesting. Thank you and all the best.